The water turns cold. Welcome to Wild Facts Daily. Hit the bell and subscribe. A sudden deep quiet descends upon the sunlit kelp forest, a silence so profound it feels as if the ocean itself is holding its breath. The smaller fish have vanished, darting into rocky crevices. Seals, usually boisterous and playful, slip away from their sunning rocks, melting into the shadows. Something immense is coming. A long, powerful shadow glides through the hazy blue. A great white shark, nearly 5 meters of muscle and teeth. But today, the king is being hunted. The silence is for what follows it. Two larger shadows emerge, sleek and impossibly fast. Black and white, the stark geometric patterns of orcas. Image. Two orcas, a large male and a smaller female, swimming side by side in the open ocean. They move with unnerving grace, massive bodies cutting the water. The great white suddenly seems small, almost clumsy. The lead orca, a colossal bull with a scythe-like dorsal fin, positions itself. No frenzy, no chaotic thrashing. This is not a fight, it is an execution. The natural order is being rewritten. The moment of the strike, precision. So why would an orca, a creature of immense power and intelligence, choose to hunt such a formidable adversary as a great white shark? The answer, it seems, is remarkably simple and yet deeply fascinating. It is not for sport, nor is it a random act of aggression. Here's a wild fact. Orcas hunt great white sharks for a very specific and valuable prize: their liver. Here's a wild fact. The shark's liver is an enormous organ, accounting for up to a quarter of its total body weight. Here's a wild fact. It is exceptionally rich in oil and fats, packed with a nutrient called squalene. For an orca, this represents an incredibly dense source of calories, a superfood of the deep. This targeted feeding is a testament to the orca's incredible understanding of anatomy and its own nutritional needs. Instead of consuming the entire shark, which would involve dealing with tough skin and less nutritious muscle, the orcas have learned to extract only the most valuable part. It is the oceanic equivalent of a child eating only the filling of a pie, leaving the crust behind. This behavior has been observed time and again. After a successful hunt, the carcass of the great white shark is often found washed ashore or drifting in the current, largely intact but for a precise gaping wound from which the liver has been expertly removed. Furthermore, this behavior isn't just about securing a high-energy meal, it is also about eliminating competition. Orcas and great white sharks are both apex predators, occupying the very top of the marine food web. Here's a wild fact. It begins with detection. Orcas possess echolocation, a biological sonar that lets them see with sound. They emit clicks, they emit whistles, then interpret the returning echoes to build a detailed picture. This allows them to locate a great white from a distance, assessing its size and direction long before sight. The shark relies on smell and electrical detection, and is often unaware it is being stalked. Once identified, the pod coordinates. Orcas are social hunters. Success relies on teamwork. They use complex calls, assign roles, and synchronize movements. One orca approaches, two orcas approach, acting as a diversion. They swim parallel to it or bump it gently, testing reactions and herding it toward open water. Away from reefs, away from the seabed. All about control, manipulating behavior and setting the stage. The shark is outthought at every turn. Here's a wild fact. Key weakness: tonic immobility, paralysis when turned upside down. Orcas have learned and perfected inducing it. The method: a high-speed lateral strike. An orca accelerates and rams the side, aiming near the pectoral fins. The force flips the shark onto its back. It requires precision, it requires speed, it requires power. Once inverted and helpless, orcas take their time. They no longer need to worry about the jaws. They carefully extract the liver. One of the first and most dramatic documented accounts of orcas hunting a great white shark took place on October 4, 1997, near the Farallon Islands off the coast of California. This area, known as the Red Triangle, has long been famous for its large population of great whites, which are drawn there to feed on the abundant elephant seals. On that day, passengers aboard a whale-watching boat witnessed an event that would change our understanding of the ocean's hierarchy. The encounter involved a large female orca, later identified by researchers as CA2, and a 3-meter-long great white shark. The event, captured on film, unfolded with astonishing speed. The orca charged the great white at high speed. There was none of the tentative circling one might expect. The orca struck with immense force, a single, decisive blow that sent the shark into the air. The shark appeared stunned instantly. The orca held the shark in its mouth for a short period, then dove deep, taking its prize with it. The whole interaction lasted less than 15 minutes, a swift, brutal display of dominance. What followed was even more remarkable. The orca resurfaced shortly after, not with the whole shark, but carrying only its massive, oily liver. The rest of the carcass drifted away. This was the first concrete filmed evidence of orcas targeting the liver of great white sharks. It confirmed what some scientists had long suspected. To truly understand why orcas can dominate great white sharks, we must look beyond their physical attributes and delve into the complexities of their minds. Orcas possess the second largest brain of any animal on Earth, surpassed only by the sperm whale. But it is not just the size of the brain that matters. It is how it is structured and how it is used. The orca brain is highly convoluted, with an incredibly complex neocortex. Higher-order thinking, problem-solving, social cognition. This intelligence manifests most clearly in their capacity for culture. Different pods of orcas around the world have developed their own unique traditions, dialects, hunting techniques, which are passed down from one generation to the next through social learning. The strategy of flipping a shark to induce tonic immobility is not an innate, hardwired instinct. It is a learned skill, a piece of cultural knowledge that a mother teaches her calf. We have observed young orcas watching their elders hunt, seemingly practicing the necessary moves on smaller prey before attempting to take on something as formidable as a great white shark. Dr. Ingrid Visser, a renowned marine biologist who has spent decades studying orcas, puts it this way: "It is not just about brawn, it is about brains." The orcas are outthinking the sharks. This quote, from her research published in the journal Marine Biology, encapsulates the essence of this dynamic. The sharks are operating on instinct, driven by millions of years of evolutionary programming. The orcas, however, are operating on a different level. They are observing, learning, innovating, teaching. They can adapt their strategies to different situations and different types of prey, a cognitive flexibility that the shark simply does not possess. The ascendancy of the orca over the great white shark has profound and far-reaching consequences for the marine ecosystem. Great white sharks, as apex predators, play a crucial role in maintaining environmental health. Here's a wild fact. They regulate populations in the food web, such as seals, large fish. By preying on the sick, old, weak, they help ensure genetic fitness. Their presence signals a healthy, functioning ecosystem. When they disappear, the effects ripple outwards. In places like False Bay, Gans Bay, once hotspots for shark tourism, the arrival of liver specialist orcas, port and starboard, led to near-total collapse of local shark numbers. Since 2017, sightings have plummeted. Sharks were killed or fled to safer waters. This shark scare phenomenon, where orcas clear territories of sharks, shows a landscape of fear. The absence of great whites creates a power vacuum. Mid-level predators, like the bronze whaler shark, are increasing. Cape fur seals may boom without their main predator, but unchecked numbers can cause overgrazing and spread disease, destabilize the coastal food web. We're seeing a real-time restructuring of the marine ecosystem. In the grand silent theater of the ocean, the drama between the orca and the great white shark is a powerful story of intelligence triumphing over instinct. We have seen how the orca's sophisticated brain, its capacity for cultural learning, its complex social structure have allowed it to develop hunting strategies that can overcome the raw power of the ocean's most iconic predator. The targeted removal of the shark's nutrient-rich liver is not an act of malice, but a calculated, efficient, learned behavior, a testament to the orca's place as the true apex predator of the seas. This is the calm, scientific reality behind the shocking spectacle. The evidence is now undeniable, from the filmed encounter at the Farallon Islands in 1997 to the recent dramatic displacement of sharks in South Africa. Necropsies of washed-up shark carcasses reveal the orca's surgical precision. Electronic tagging data shows the sharks' panicked flight from their historical feeding grounds. These events are not isolated incidents but data points in a growing body of evidence. They paint a clear picture of a shift in the balance of power, driven by the remarkable cognitive abilities of one species. The reign of the great white shark as the unchallenged king of the ocean appears to be over. This shift forces us to reconsider our long-held perceptions of the marine world. Nature is not static, it is dynamic, constantly adapting and evolving. As one apex predator displaces another, what other unforeseen changes will ripple through the depths, and what will the ocean of tomorrow look like?